Bubble sort, an algorithm to sort elements such as array of integers. Not very efficient but easy to implement. So let's see how it works. Initially, we have an unsorted array of integers and we need to sort it. The fundamental concept of bubble sort is to find the largest element of the unsorted portion and move it at the end of the unsorted portion. For example, initially the entire array is unsorted and the largest element is 7. So we need to move 7 at the end of the array. And how do we do that? Well, it's pretty simple. We start from the beginning of the array, take two consecutive elements. If the first element is greater than the second one, then we swap them and move ahead. And do the same. Check if the first element is greater than the second. If so, then swap. As you can see, we are basically shifting or bubbling the largest element at the end of the array. After the first iteration, the largest element 7 is at the end of the array where it should be in the sorted array. We do the same thing starting from the beginning, taking two consecutive elements, checking if the first one is greater than the second one. If true, then swap them and move ahead. Here is the code of bubble sort implemented in Python. Let's go through the code line by line. In the second line, the length of the array is stored in a variable named n. In line 3, a for loop is started which runs n number of times, and in each iteration we find the max integer from the unsorted portion of the array and move it at the end of the unsorted portion. In line 4, a variable named swapped is defined to store if during the current iteration any two numbers are swapped or not. This is to further optimize the code. If no two integers are swapped during any iteration, it means all the integers are sorted. So we can stop the iteration and return. In line 5, we start the second loop which iterates over the unsorted portion of the array. You can see after each iteration of variable I, length of the unsorted portion decreases by 1 as indicated by n-i-1. During this iteration of the second for loop with variable j, we take two consecutive integers and check if the first integer is greater than the second integer, which is done in line 6. If the first integer is greater than the second integer, then we swap them. In our case, the first two consecutive integers are 3 and 0. As we can see, 3 is greater than 0, so we swap them. From line 8 to 10, we swap these two integers. Then move one step ahead in the array and check if 3 is greater than 5 or not. As 3 is smaller than 5, so we don't swap them and move one step ahead and compare 5 and 2. 5 is greater than 2, so we swap them. In line 11, we check if any two integers were swapped during the iteration. As we have swapped some integers during this iteration, so we won't stop. Now the first iteration over the unsorted portion is done, and as we can see, the largest integer 5 is at the end of the unsorted portion where it should be in the sorted array. Next we go for the second iteration over the variable I, do the usual stuff, iterate over the unsorted portion, swap two consecutive integers if the first integer is greater than the second integer. Do this until the whole array is sorted. As we have used two nested loops, so the time complexity is big O of n square, which is not very efficient. Later we will see how to implement more efficient algorithm like quicksort and merge sort. If you enjoyed this video, then hit the like button. Thank you all for watching. I will see you in the next video.